So number one is set up perfectly for elimination because we should notice that the coefficients of the x's in this case are equal and opposite. So we don't have to do anything extra to this problem. Just go ahead and add the two equations together. The x's should cancel out, leaving us with negative 8y equals 40. And then we can divide both sides by negative 8 to get y equals negative 5. The moment you get a numerical answer, just substitute it back into any of the original equations. It doesn't matter which one. Let's choose the top equation by random. Substitute in y equals negative 5. So instead of a y, I'm going to substitute a negative 5 in. And then you just do math. That's plus 20 equals 20. Subtracting 20 gives us a 0. Dividing up to 3 keeps with a 0. Now remember, solutions to systems are coordinates, so my answer is 0, negative 5. Number 2 looks like it's set up for elimination as well, because notice the coefficients of x's in this case are the same. However, I actually like to go one step further and make sure that the coefficients are opposites as well. So because they're both positive, I need to multiply one of the equations by a negative. It doesn't matter which one. Let's just go ahead and do the bottom equation. So the top equation stays the same. And then multiplying the second equation by negative gives us negative 4x minus 9y equals negative 25. Now we can go ahead and add these two equations together to eliminate the x's, leaving us with y equals 1. And then substitute it back into any of the original equations. Let's, substitute the bottom equation. Why not? 4x plus 9y equals 25. So we're going to substitute a 1 in for the y. And then just do math. Let's subtract the 9 from both sides. And then divide out the 4. Leaving us with our answer of 4, 1. Number 3 is not set up for elimination. So I recognize that there is a variable with the leading coefficient of 1 or negative 1. So we could do substitution, but I think I'll go ahead and do elimination on this one. It doesn't matter which variable we eliminate. Let's eliminate the x's because, why not? So I need to find the common multiple of 16 and 8, and hopefully everyone can just know off the top of our heads that 16 is going to be a common multiple. So I'll go ahead and leave the first equation as is, not do anything to him, because the x is already a 16. Negative 16, but it's the same idea. And then hopefully we can see that we need to multiply the second equation by 2 to get this 8 to be a 16 as well. Now I like to get the coefficients to be equal and opposites. So notice how they're both negative, which means I need to multiply this guy by a negative 2 to flip the signs. So that gives us, for our second equation, a positive 16x, a positive 2y equals a positive 40. Then we can go ahead and eliminate by adding these two equations. The x's are gone, leaving us with a negative 5y equals a positive 20. Divide both sides by negative 5 gives us y equals negative 4. Substitute it into any of the original equations. Let's say the bottom equation. Negative 8x minus y equals negative 20. And then substitute a negative 4 for the y. Negative 8x plus 4 equals negative 20. Subtract 4 from both sides gives us negative 24. And then divide both sides by negative 8 gives us a positive 3. So there's our solution, 3, negative 4. Number 4 here, none of the coefficients are the same. So 3 and 7 are different, 7 and 2 are different. So if I want to do elimination, I need to multiply to get them to be the same. It doesn't matter which variable we eliminate. Let's eliminate the x's. So 3 and 7, notice I'm ignoring the negatives. Hopefully we can all agree that 21 is a common multiple. So that means I need to multiply the top equation by a 7 and the bottom equation by a 3. Now, notice how the symbols, they're both negative. I actually like to go the extra mile, make sure that they are opposite symbols. That means I need to multiply one of the equations by a negative. It doesn't matter which one. Let's, Multiply the bottom equation by a negative. Why not? Right. So that gives us a top equation. If I distribute a positive 7 and negative 21x plus 49y equals negative 203. Okay. And then for the bottom equation, we get a positive 21x, a negative 6y equals a negative 12. So now when I go ahead and add these two equations, the x's should cancel, leaving us with a positive, what's that, 43y equals a negative 215. Crossing my fingers that this divides nicely and evenly. So 2 divide both sides by 43 gives us negative 5. Hey, that works. So then we substitute y equals negative 5 into any of the original equations. Let's do the bottom equation because the numbers look small. So the bottom equation here, we're going to substitute a negative 5 in for the y. Do some math here. Add 10 on both sides. And then divide both sides by negative 7, giving us x equals negative 2. So there's our solution, negative 2 comma negative 5. Number 5 here, notice the coefficients are not the same. So if I want to do elimination, we're going to have to do some multiplication. Let's eliminate the y's in this case because the numbers are smaller. That's just my reason. There's no right or wrong rationale for elimination. You just have to eliminate one variable. So hopefully it doesn't take a lot of thinking. If I'm eliminating the y's, a 3 and a 5, the common multiple is 15. So I need to multiply the top equation by a 5 and the bottom equation by a 3. I also want them to be opposite symbols, and notice how they're already opposites. One's positive, one's negative. So I don't need to fuss with any extra negatives. You should go ahead and multiply it as is. So multiplying the top equation by 5 gives us a negative 45x minus 15y equals negative 15. And then for the bottom equation, that gives us a 21x plus 15y equals negative 9. We can go ahead and add these two equations. So that gives us a negative 24x equals a negative 24 because of the y's cancel. And then divide both sides by negative 24 gives us x equals a positive 1. We'll go ahead and substitute x equals 1 into any of the original equations. It doesn't matter which one. Let's use the bottom equation because, I don't know, it looks more positive. But you plug it into any equation that you want. So substituting an x equals 1 into the equation. Do some math. 7 times 1 is 7. Subtract by 7 from both sides. Gives us 5y equals negative 10. And then divide both sides by 5. Gives us y equals negative 2. So there's our solution. 1 comma negative 2. Number 6, the equations are lined up, so I could use elimination here. Or notice how the equation, one of the variables already solved for. That's a classic sign of substitution. So basically, because the equation's already solved for one variable, y equals or x equals, you take the whole equation here and substitute into the second equation wherever we see a y. So basically, since both equations are y equals, you just set them equal to each other. Y equals y. So therefore, 3x plus 1 must equal negative 8x minus 21. And then this is just a regular linear equation to solve for x. Let's go ahead and add 8x to both sides, while at the same time subtracting a 1 from both sides, giving us 11x equals negative 22. Divide both sides by 11, gives you x equals negative 2. Once you have a numerical answer, substitute it back into any of the original equations. Let's substitute into the top equation. Why? Because, I don't know, the numbers look smaller to me. But you can substitute into any equation you want. So plugging in a negative 2 for the x. We do some math. That's negative 6 plus 1, which is negative 5. So there's our solution, negative 2 comma negative 5. Notice number 7 is the same setup. Both of the equations is already y equals, so you can just set both equations equal to each other. Negative 6x minus 20 equals negative 7x minus 22, and then just go ahead and solve for x. So let's add 7x to both sides, while at the same time adding 20. I want to get all the x's on one side, all the non-x's on the other. So that gives me an x equals negative 2. Well, that was simple. That was nice. Didn't have to do a lot of math there. So then substitute to any of the original equations. Let's substitute it to the top equation. Why not? They both equations look equally bad. So substitute a negative 2 in for the x. And then do some math. Negative 6 times negative 2 is a positive 12. 12 minus 20 is a negative 8. So there's our solution. Negative 2 comma negative 8. Number 8, I recognize that one of the equations is y equals, so I can just go ahead and straight up use substitution. That means I'm going to substitute the whole equation, 3x plus 11, into the other equation wherever I see a y. So rewriting the second equation gives me negative 2x minus 3, but instead of writing a y, I'm going to substitute the entire 3x plus 11. And then you just do math. Distribute. That's a negative 2x minus 9x minus 33 equals 11. Let's combine like terms. Negative 11x minus 33 equals 11. Add 33 to both sides. Negative 11x equals 44. Divide both sides by negative 11x equals negative 4. And then all you have to do is substitute x equals negative 4 into any of the original equations, the first one or the second one, it doesn't matter. Since the first equation is already solved for y, that might be the easiest one to use. So substituting a negative 4 in for the x, doing some math, 3 times negative 4 is negative 12, and negative 12 plus 11 is a negative 1. So there's our solution, negative 4 comma negative 1. Number 9, they're all mixed up. So we can use elimination or substitution in this case. It doesn't really matter. Let's showcase substitution because for the entire video I've sort of been doing elimination here. The idea with substitution is it's easiest if you solve for a variable that doesn't have a visible number in front of it. Hopefully we can see that this x does not have a visible number in front of it. So that might be the easiest one to work with first. So I'm going to write down the second equation. And let's go ahead and solve for x, which is just one step here, adding the 5y over. So that gives us x equals negative 12 plus 5y. So now that I have a variable solved for, x equals whatever, by substitution, that means I'm going to take this entire expression and substitute it into the other equation wherever I see an x. So to rewrite the top equation, we have negative 6, but instead of writing an x, I'm going to substitute a negative 12 plus 5y, and then finish the rest of the problem, plus 3y equals negative 9. And then the rest is math. Distribute, so that's a positive 72 minus 30y, plus 3y equals negative 9. Let's combine like terms. 72 minus 27y equals negative 9. Let's subtract the 72 over. So that's negative 27y equals negative 81. And let's divide both sides by negative 27, giving us y equals a positive 3. Now that I have a numerical value for y, you can substitute it into any of the original equations, or you can substitute into the equation that has x already solved for, and that's what I'm going to use. So you have x equals negative 12 plus 5y. Substitute a 3 in for the y, gives us 5 times 3, and then you just do math. X equals negative 12 plus 15, so x equals 3. So there's our solution, 3 comma 3. Number 10, well, none of the coefficients are the same here, so that's different, that's different. So I would have to use multiplication if I wanted to eliminate. One thing we should notice is that one of the variables does not have a visible number in front of it. So substitution might be a valid way to go here. So for this solution, for this example, let's Oh, the numbers are pretty big. Let's go ahead and just use substitution. So we're going to solve for the variable that doesn't have a visible number in front of it. So I'll take the first equation, negative 6x minus y equals 15, and let's solve for y. We'll add the 6x over, and then to get rid of the negative in front of the y, you just divide everything by negative 1. That has the net effect of flipping all the signs. So a positive y equals a negative 6x minus 15. So that means I'll substitute this expression, negative 6x minus 15, into the other equation wherever I see a y. So that's the second equation. So that's 7x plus 7. Instead of a y, I'm going to write negative 6x minus 15. And then you just go ahead and do math. Distribute. 7x minus 42x. And then 7 times 15 is, what's that? Negative 105. 70 plus 35, yep, equals 0. Then you just combine like terms. So that's a negative, 35x minus 105 equals 0. Add the 105 over, and then divide out the negative 35, giving us, crossing my fingers, this goes in evenly, negative 3. Awesome. And the moment you have a numerical answer for a variable, substitute it into any of the original equations, or you can substitute it into the solved equation that you did earlier. And I think I'll go that route. So we have y equals negative 6x minus 15, y equals negative 6 times negative 3, because that's what x was, minus 15, y equals a positive 18 minus 15, y equals a 3. So there's our solution, negative 3 comma 3. Number 11, when it comes to three equations, three variables, I almost always use elimination. So let's call this equation 1, equation 2, equation 3. Step 1 is to pick any two equations and eliminate a variable. It doesn't matter which one. So I'll just pick equation 1 and 2. So we have negative 5x plus 4y plus 6z equals 27. Negative 2x plus 5y minus 3z equals negative 25. And then eliminate any variable that you want. I'll go ahead and eliminate the z's. So there's nothing I need to do to the top equation. But I will go ahead and multiply the bottom equation by 2 because I want to get the z's to have the number 6. That's the common multiple. Notice how they're already opposites. One's positive, one's negative. So I do not have to fuss with any extra negatives. So multiplying the bottom equation by 2 gives us negative 4x plus 10y minus 6z equals negative 50. So then I can go ahead and add these two equations together, giving us a negative 9x plus 14y. The z's cancel out, leaving us with a negative, 23. There's not much I can do with this right now, so I'll go ahead and save him. So I'll highlight him to save him. But basically, we got to start all over. So go back to the drawing board. Pick two new equations. It doesn't matter which two. Let's say equation 2 and equation 3. So equation 2 is negative 2x plus 5y minus 3z equals negative 25. And equation 3 is 2x minus 2y minus 3z equals negative 14. When you do the second step, you must eliminate the same variable as you did before. So since we eliminated the z's before, we have to eliminate the z's now. Fortunately for us, they're already the same number, so I'm happy, that's good. But notice how they have the same symbol. They're both negatives, which means to eliminate, I need to multiply one of the equations by a negative number, by a negative 1. It doesn't matter which one. So choosing by random, let's multiply the top equation by a negative 1. So that gives us a positive 2x minus 5y, positive 3z equals a positive 25. And then for the bottom equation, it stays the same. 2x minus 2y minus 3z equals negative 14. So now when we add these two guys together, the z should cancel. So that gives us a 4x minus 7y. The z's are gone, equals, what's that? That's an 11. So then we'll go ahead and save these guys here. Now the idea is that you put your two saved equations together and you basically repeat the process. repeat the process of elimination. So I'm running out of room here, so let's hope I can squeeze it into here. So you take your two saved equations, negative 9x plus 14y equals negative 23, 4x minus 7y equals 11, and then you eliminate like normal. So I don't know, let's eliminate the y's here. So hopefully we can see that 14 and 7, the common number is 14. So the first equations, I don't have to do anything, just stays as is. And then for the second equation, I need to multiply by 2. So that gives me an 8x minus 14y equals 22. So when I add these two equations, that gives me a negative x, the y's are gone, equals negative 1. So positive x equals a positive 1. Here's the idea. The moment you get a numerical answer, you always substitute it into an equation that has one more variable. So I only have one numerical answer. I'll substitute into an equation that has two variables. And just looking at what we have in front of us, we only have two choices. It's the yellow equation or the orange equation. I'm going to substitute into the orange equation because, the numbers seem smaller. So we have a 4x minus 7y equals 11. X we said was 1. And then you just do math. 11. There we go. Subtracting the 4 gives me negative 7y equals 7. And then divide both sides by negative 7 gives us y equals a negative 1. Right? The moment you have two numerical answers, you substitute into the equation that has three variables, which is the originals. It doesn't matter which one we substituted it in. I'll substitute it into the third equation because, again, the numbers look small. No rhyme or reason. Well, I guess that is a reason. So it's personal preference. There's no wrong choice. So x was 1 minus y was negative 1. I'm running out of room here, so I'll just do a lot of mental math. So that's 2 plus 2 is 4. Minus the 4 gives me a minus 18. Divide both sides by negative 3 gives us a 6. So there are our three values. But remember, solutions are points. So we have to write it in alphabetical order, x, y, z. So my answer is going to be 1, comma, negative 1, comma, 6. Number 12 here, same concept. So let's label this as equation 1, equation 2, equation 3. So the idea to solve three variable systems is just basically do a whole bunch of eliminations. First step, pick any two equations and eliminate any variable. Let's pick, I don't know, the first and second one. Why not? So I'll pick equation 1, 3x plus 2y minus 2z equals negative 20. Equation 2, 3x minus 2y plus 2z equals 8. And then eliminate one variable. Now in this case, I don't have to do anything fancy. The y's and z's are already set up to eliminate. So just go ahead and add it as is. Gives us 6x equals negative 12. Now this is a special case. We had multiple variables cancel out. We should be happy. That means it's less work for us. So I can immediately solve for x. So this gives me x equals negative 2. But just like in problem number 11, if you haven't seen that problem yet, just go ahead and rewind the video and watch it. You want to save this result. Even though it's an answer, I'm going to save it, and then we have to start all over. So go back to the original system and pick two different equations now. Let's say by random, I'm going to choose equation 1 and equation 3. So equation 1, 3x plus 2y minus 2z equals negative 20. Equation 3, now that equation 1 and 3 would probably, yeah, that would work. So negative 3x minus 2y plus 3z equals 24. And then we have to eliminate the same variable as before. Now in step 1, we eliminated the y's and the z's. So in step 2, I need to either eliminate the y's or eliminate the z's. But hopefully we can see in this case that, again, we should be happy, we're lucky, that multiple variables cancel out. So in this case, if I add these two equations, the x's are gone, the y's are gone, leave me with z equals 4. So this is actually a pretty rare situation. This is a special situation in that when we did the elimination twice, we went straight to the answer. So normally, just like in example number 11, problem number 11, if you rewind the video and watch it, we would have to put the yellow and the orange equations together and solve the system. But guess what? There is no solving. We're 2/3 done because we have a numerical number for x, we have a numerical number for z. So then all you got to do is substitute those numbers back into any of the original equations. It doesn't matter which one. I'm going to choose the second one because the numbers look small. And then just plug in the numbers that we have. We know that x is -2. We don't know what y is, but we do know z is 4. And then you just go ahead and do math. So that's -6 minus 2y plus 8 equals 8. Combine like terms. -2y plus 2 equals 8. Subtract the 2. -2y equals 6. Divide out the -2. Y equals -3. So those are our individual answers, but remember solutions are points, so write it as an ordered triple, x, comma, y, comma, z. So our solution would be -2, comma, -3, comma, 4. Pretty cool. Number 13 is another example of a 3-variable system. So let's call this equation 1, equation 2, equation 3. And it doesn't matter which one we pick. So let's pick equation 1 and 2. So we have a 3x minus 2y plus 2z equals 19. -2x minus 6y plus 4z equals 2. It doesn't matter which one we eliminate. Let's eliminate the z's because I feel like it. So the common number between 2 and 4 is 4. So I need to multiply the top equation by 2. But notice how they're both positive. I want them to be opposite, so we'll multiply by -2 here. So this gives us a -6x plus 4y minus 4z equals a -38. And the bottom equation stays the same, -2x minus 6y plus 4z equals 2. So we can see that when we add these together, the z's will cancel, leaving behind a -8x minus 2y equals a -36. And then what you're going to do is just save this equation. There's not much we can do with them now, but we'll save them. So step 2 is to start over. Go back to the original system, pick, that should be a 3, pick any a different pair of equations. It doesn't matter which one. So we picked equations 1 and 2 to start with. So let's do, 1 and 3. Why not? Just because I feel like it. So equation 1, 3x minus 2y plus 2z equals 19. Equation 3 is -5x minus 3y minus 5z equals -19. And the idea is we have to eliminate the same variable as before. So in step 1 we eliminated the z's. In step 2 we have to look at the z's again. So we have a 2 and a -5. Hopefully everyone knows that the common multiple between 2 and 5 is 10. So the first equation needs a 5. The second equation needs a 2. Notice that the symbols are already opposites, so I do not need any extra negatives. So multiplying through gives us a 15x minus 10y plus 10y equals, what's that, a 95? Yeah. And then the second equation, distributing a 2, gives us a -10x minus 6y minus 10z equals -38. So when we add these two equations together, the z's cancel, leaving behind a 5x minus 16y equals, what's that, 57. So then we'll go ahead and save this guy here. So the idea is that you put your two saved equations together, -8x minus 2y equals -36. 5x minus 16y equals 57, and then you just go ahead and solve that equation however you want. We'll go ahead and solve it by elimination, and let's eliminate the y's here, which means we need to multiply the top equation by -8, giving us a positive 64x plus 16y equals 36 and 8. So that's a 48, 4, 24, 28. So a positive 288. And then we don't have to do anything with the bottom equation. 5x minus 16y equals 57. Go ahead and add these two guys together. Gives us a 69x. The y's are gone. Equals 5, 1, 13, 14, 345. And I'm going to have to whip out my calculator here. I'm hoping when I divide both sides by 69, 345 divided by 69, hey, what do you know? It goes in perfectly. X equals 5. Then you take that result and substitute it into any of the two variable equations, the yellow or the orange. It looks like the yellow has slightly smaller numbers, so I'll plug into the yellow equation. So negative 8 times 5 minus 2y equals negative 36. Do some math. Negative 40 minus 2y equals negative 36. Add the 40 over. And then divide out the negative 2. So y equals negative 2. And then to solve for z, you substitute into any of the original equations. Let's substitute into the second equation because the numbers look small. So the second equation is negative 2x, which we said was 5, minus 6y, which we said was negative 2, plus 4z, which we don't know, equals 2. And then we'll just do some mental math. Since I'm running out of room, I'll go ahead and just do the math in my head. So that's negative 10 plus 12 is a 2. Subtract the 2, and then you get z equals 0 when you divide out the 4. Okay. So there's our answer, x comma y comma z. So we have 5 comma negative 2 comma 0. So number 14 is a word problem. Now there are no secrets or to word problems. You just have to be able to read it and parse the information. So assuming that you guys have read it, the first thing I'd like to do is sort of hone in on what the actual question is asking, which is the very bottom here. Find the cost of each pecan cheesecake and strawberry cheesecake. So those are my variables. So I'll make x equals the cost of one of them. Let's say cost of one pecan, and I'll make y equals the cost of one strawberry. Right? They're both cheesecakes, but I'm not going to write it. So let's just go ahead and read and try to connect the information together. We have 4 pecan sold, 12 strawberry sold, and they give us a total of 244. Excuse me. I have more information. 7 pecan, and notice I'm using yellow for pecans, 6 strawberries, and they give us another total, 142. So then basically you just have to link the information with the variables. Now, one of the hints or suggestions I gave in class is anytime they give you a total, that's usually going to be on its own on one side of the equation. So $244, that's a total. So I know one equation will be 244 equals. Where did that 244 come from? It came from 4 pecans and 12 strawberries. So I know that pecans are yellow, so this 4 cheesecake will connect, or 4 pecan cheesecakes will connect with the x. So I know that 244 is going to have to equal the 4x and then the 12y. There's one equation. And then you do the same thing with the 142. The 142, where did that 142 come from? It came from 7 pecans and 6 strawberries. And there's no big secret. You just have to be able to read it and set up the system. So then you just solve it like a normal system. Let's solve it by elimination. So I'll multiply the second equation by negative 2. So that gives us 244 equals 4x plus 12. That gives us a negative 284 equals negative 14x minus 12y. The y's cancel when I add the equations, giving us a negative 40 equals negative 10x, so x must equal 4. And then when you go ahead and substitute back into any of the original equations, let's substitute in the bottom equation. We have 142 equals 7 times 4 plus 6y. 142 equals 28 plus 6y. Subtract the 28, so that's what? 12, 11, 12, 114 equals 6y. And crossing my fingers, when I divide by 6, 114 divided by 6 gives us a 19 equals y. So there's the solution. Find the cost of one pecan cheesecake and one strawberry cheesecake. We said that x was pecan, y is strawberry. So pecan cheesecake is $4 per, and strawberry cheesecake is 19 per. So that should have been the solution.